Hello everyone, in this video we will learn all about radicals. Now given this radical term, the cube root of 64, this is the radical sign. 64 is considered as the radicand, so when you say radicand, it's the number within the radical sign. This 3 here is considered as the index, so an index is written at the wing of the radical sign. So if an index is not written, the default there is 2. Now when you simplify this further, the cube root of 64, the result here is 4. This 4 here is considered as the root. Now the root relates with the radicand by multiplying by itself by the number of times equivalent to the index. So since the index here is 3, so we need to multiply 4 by 3 times. 4 times 4 times 4, so therefore it is 64. Now these are perfect square numbers with their corresponding square root. Now take note, when you multiply the square root by itself, you will get the perfect square numbers. Like 1 times 1, you'll get 1. 2 times 2, you'll get 4. 3 times 3, you'll get 9. 4 times 4, you'll get 16, and so on. This one here are perfect cube numbers with their corresponding cube root. So take note, when you multiply the cube root by itself 3 times, you will obtain the perfect cube numbers. Like 1 times 1 times 1, you'll get 1. 2 times 2 times 2, you'll get 8. 3 times 3 times 3, you'll get 27, and so on. Now, to be able to identify the square root of a number, we need to take note of the following properties. The first one here is this one. This is the nth root of a to the power of n. So the result here is a, as long as the n is odd. For example, the cube root of 4 to the power of 3 is 4. Another, the nth root of a to the power of n is the absolute value of a if the n is even. So for example, the fourth root of negative 3 to the power of 4, the result here is positive 3. Take note here, our index here is even. For the first example, the index is odd. Next, in this case, when you multiply radicals of the same base, you simply multiply the radicands and copy the index. For example, the square root of 5 times the square root of 20. So 5 times 20, you'll get 100. Since our indexes here are equal. So that would be square root of 100, or simply it is 10. Another. Now when you divide radicals of the same index, just the same thing, you simply divide the radicands and copy the index. For example, the square root of 24 divided by square root of 6. So basically, it's square root of 24 over 6. 24 by 6 is 4. So get the square root of 4. The result is 2. Now, let's have this one. Remove the radical sign. So in this case, the square root of 49, that's 7. Square root of 121x squared. So this would be 11x. Negative 169. So that would be negative 13. This one, the cube root of 4 cubed. So this is odd. So the result here is 4. This is the fourth root of negative 2 to the power 4. Take note, it's even. So the result here, get the absolute of the radicand. So it's 2. Next, the cube root of negative 5. So cube, the result here is negative 5. Now take note, example 6 and example 5. So here it's even, and here the index is 3. Next, 7. In this case, the result here is x to the power of 5. 144, square root to that is 12. Then, square root of y8, it's simply y to the power of 4. So, again, if it is an exponential term, to find its square root, you simply divide the exponent in the radicand by the index. So, in this case, 10 divided by 2, you'll get 5. 8 divided by 2, you'll get 4. Another. This one, take note, our index here is 3. So, we have 6 here. 27, the cube root of 27 is 3. And 6 divided by 3, you'll get 2. The cube root of 64 is 4. and 9 divided by 3, you will get 3. So take note of that. Now, if it involves variables already or exponential terms. This one, the square root of 0.64, that's 0.8. And the square root of 0.0081 is 0.09. Take note of this. Simplify the following. So that's one, the square root of 36 is 6, and 4 divided by 2 here, so the result here is x squared. Next, cube root of 27. 27 is a perfect cube, so in which it is 3, and 12 divided by 3, you will get x to the power 4. That's one, cube root of 3, still 2, and 6 divided by 3, you will get 2. This one, the fourth root of 81 is 3, and 16 divided by 4, you'll get 4. Okay, this one. Now take note, 20 is not a perfect square, but you can rewrite this as 4 times 5. So why 4 times 5? Because 4 is a perfect square, and it is a factor of 20. 4 times 5 is 20, and 4 is a perfect square. So therefore, the simplified answer here, square root of 4 is 2 square root of 5. Next, 54 is not also a perfect square, but you can rewrite this as 9 times 6. 9 times 6 is 54, and the square root of 9 is 3, and square root of 6. This one, 24 is not a perfect cube, but you can write this as cube root of 8 times 3. 8 is a perfect cube, and the cube root of 8 is 2, but still writing cube root of 3. Next, fourth root of 162. You can rewrite this as 81 times 2. Now here, 81 times 2 is 162, and the fourth root of 81 is 3 fourth root of 2. So take note how it is done in case the radicand is not a perfect square. Next, now here, the radicands here are not also perfect radicands. So how are you going to do it? So in this case, our index is 2. So we need to rewrite x to the power of 5 into x to the power of 4 times x. So why 4? Because 4 is a factor or a multiple of 2 nearest to 5. So with this, 4 divided by 2, so we will get x squared, but still with the remaining x. Okay, that's one for number 2. So you have your 3 and you have 14. So factor of multiple of 3 nearest to 14 is 12. So that would be cube root of x 12, but with the remaining 2. So take note, 12 plus 2, you'll get 14. So at this point, 12 divided by 3, so you will get x to the power of 4, but with the remaining cube root of x squared. Okay, so take note how it is done. Now this one, this is fourth root of x to the power of 23. So factor of 4 nearest to 23, that would be 20. So 20 plus 3, you will get 23. 20 divided by 4, you will get x to the power of 5, but with the remaining fourth root of x cubed. Or it simply means 5 divided by 2, you will get 2 remainder 1. Another, 14 divided by 3, you will get 4 remainder 2. And 23 divided by 4, that would be 5 remainder 3. So that's how are you going to do it. Okay, this one. What is the square root of 12x cubed? Now take note, 12 here is not a perfect square, but you can rewrite this as 4 times 3 x to the power of 3. Now take note here, our index is 2. So to simplify this further, the square root of 4 is 2. And take note here, 3 divided by 2, you will get 1 remainder 1. So take note how it's done. Let's have another example. 49 x to the power of 5. Take note, 49 is a perfect square. So square root of 49 is 7. And take note, we have 5 here. 5 divided by 2, you will get 2 remainder 1. So take note of that. Another. 50 x to the power of 11. Take note, 50 is not a perfect square, so you can rewrite this as 25 times 2 x to the power of 11. The square root of 25 is 5. 11 divided by 2, you will get 5, remainder 1. So take note of that. Okay, next. This one here is cube root of 27x to the power of 8. Take note, 27 is a perfect cube. So the cube root of 27 is 3. And this one, 8 divided by 3, you will get 2, remainder 2. So take note how it's written. And last, we have here the cube root of 8x to the power of 6, y to the power of 10. Take note, 8 is a perfect cube. And the cube root of 8 is 2. 6 divided by 3, you will get 2. And 10 divided by 3, you will get 3, remainder 1. So take note how it is written. Okay, now we have here 3 to the power of 2, which is 9 in exponential form. Again, rewriting this to rational form, as we learned in the previous video, we have here 9 to the power of 1/2 is equal to 3. Or, in radical form, we can rewrite this as the square root of 9 is equal to 3. So take note, the denominator here indicates the index. Next, 5 cubed is 125. You can rewrite this as 125 to the power of 1/3 is equal to 5. So take note, the denominator is 3 here. So you can rewrite that in index form as the cube root of 125, which is 5. Now take note, the fractional exponent, in general, if you have x to the power of 1 over n, it's basically the nth root of x. So take note how it is done. Okay, now let's rewrite this from rational to radical. Now take note, 5 to the power of 3 over 4. The 4 here is our denominator, so automatic this will be our index. So that would be 4th root of 5 cubed. This one here, our denominator is 11, so that will be our index. So that would be 11x to the power of 1. And take note here, 5x to the power of 7/2. Take note, the 7/2 only apply in x. So writing this in radical form, this would be 5, the square root of x to the power of 7. Take note. Next, this one is 1 over 3 and 8 over 3. So take note, both of them, the denominator is 3. So therefore, our index here will be 3, then x to the power of 1, and y to the power of 8. Next, this one, we have here an exponent and raise further to another exponent. So it's a power rule. So to rewrite this in radical form, it will be like this. So start with the innermost expression. So since here 2 is not part of the exponent 1 over 5, so write 2 here. 5 will be our index, then square root of x. Now take note, this one is still raised further to 1/3, in which our index will be 3. So this will be cube root of this one. So take note how it is done. Another. Now this time, from radical, we will rewrite to rational. So take note here, our index here is 2 because it's not written. So writing this to rational form, this would be t to the power of 5 over 2. Now this one here, 8 is not part of the radical. So this would be 8. Then a, 11 over 4. And this one here, 5, our index. So that would be a minus 3 to the power of 2 over 5. Now this one here is double radical. So again, start with the innermost. So with the innermost, this would become x is equal to 1/2, but still raise further to 1/3. Okay, next, this one. This would be b cubed c6 to the power of 1/3. So take note, that's how are you going to convert from radical to rational form, or vice versa. Now, in simplifying radicals, there are 4 things that you need to consider. Number 1, other than 1, the radicand has no perfect square or perfect cube factor. So, for example, square root of 75, you can still rewrite this to the lowest term by rewriting 75 to 25 times 3, getting the square root of 25. So, the lowest term for this would be 5 square root of 3. Next, the exponent in the radicand should be smaller than the index. So, for example, cube root of x to the power of 7. This time 7 is still bigger than 3. So, with this, you can rewrite this as x to the power of 6 times x. So, 6 divided by 3. So, the final answer here would be x squared cube root of 6. Or 7 divided by 3, you will get 2 remainder 1. Next, number 3, no fractions appear in the radicand. So with this, for example, this one, you can still rewrite this to lowest term. So square root of 25 is 5, square root of 16 is 4, and the square root of x to the power of 8 is x to the power of 4. Okay, next, number 4. No radical sign appears in the denominator. Now, the mathematical term for this is rationalizing the denominator, or rationalize the denominator by removing the radicals from the denominator. So, now there are 2 ways of doing it. Number 1, if in case the denominator is a single radical term. So, to do this, to rationalize this, we need to multiply the top and the bottom by the radical in the denominator. So, in this case, multiply this by square root of y and square root of y. So, multiply this one, x square root of y, and y times y, that would be square root of y squared. So, simplifying further, you can cancel square and the radical sign. So, this would be x square root of y over y. So, take note, the rule here in rationalizing radical is to make the denominator a perfect square or a perfect cube to be able to remove the radical sign. Okay, let's have an example. So, let's have this. So, square root of 2 over 3. So, this one, multiply the entire equation by square root of 3 over square root of 3. So, at this point, this would become square root of 6. And square root of 3 by square root of 3, that's square root of 9, or simply 3. Okay. Next. That's 1. So, multiply here by square root of 6 by square root of 6. So, this time, this will become 2 square root of 6. And 6 by 6, that's 36, or simply 6. Or you can still simplify this further to square root of 6 by 3. Okay, that's 1. This is 11. So, you need to multiply this by square root of 11. So, this would become square root of 55. Square root of 11 by square root of 11 is square root of 121, or simply 11. Next, this one. Now, take note in number 4, the given index here is 3. So, we need to make 2 a perfect cube. So, to do that, to make 2 a perfect cube, we need to multiply the denominator and the numerator by the cube root of 4. Okay, why 4? Because 2 times 4, that would become 8, in which 8 is a perfect cube. So, take note of that. So, with this would become 4 cube root of 4 divided by 2. You can still simplify 4 by 2. So, this would become 2 cube root of 4. Okay, next, number 5. Now, at this point, the given here is 5, and take note it's cube. So, take note we need to make the denominator a perfect cube. So, to do that, we need to multiply the entire equation by 25. Okay, why 25? Because 5 times 25 is 125, in which it is a perfect cube. So, simplifying this one, this would become 2 cube root of 25 over 5. So, take note of this. Okay, now another way of doing rationalizing the denominator is by this one. If in case the denominator has a sum or difference of 2 different radicands, multiply the numerator and the denominator by the conjugate to remove the radical. So, what do you mean by conjugate? So, for example, this one, 2 minus square root of 3. the conjugate here would be 2 plus square root of 3. So at this point, it became the sum and difference of the same root. So the product here will be the difference of the square of the two roots. So square the first and square the second. So squaring the first, that would become 4, and squaring the second, this would become 3. So negative 3 by 3, that's minus 3. So simplifying further, you'll get 1. Okay, another. 3 plus square root of 5. So the conjugate here would be 3 minus square root of 5. So again, when you say conjugate, you simply make the binomials a sum and difference of the same roots, in which its product is the difference of two squares. So square the first, that would be 9, and squaring square root of 5, that would simply be 5. So 9 minus 5, this would simply be 4. So again, when you say conjugate, this is basically the sum and difference of the same roots. When you multiply them, it's basically the difference of the two squares. So take note of that. So let's have this, an example. Rationalize 2 over 1 minus square root of 5. So at this point, we need to multiply the numerator and the denominator by its conjugate, in which it is 1 plus square root of 5. Okay, so multiplying this, we will have 2 quantity 1 plus square root of 5. So at this point, 1 squared is 1. Square root of 5 squared, it's simply minus 5. So simplifying further, 1 minus 5 is negative 4. You can still simplify this. So final answer would be 1 plus square root of 5 over negative 2. Another example. This one, square root of 2 by 3 plus square root of 2. So take note. Rationalizing this, we need to multiply by its conjugates, which is 3 minus square root of 2. So simplifying further, square root of 2 by 3 minus square root of 2. So squaring the conjugates, so square of 3 is 9. Square of square root of 2 is 2. So simplifying further, this will be our final answer. So take note, this is how are you going to rationalize the denominator in case the denominator is a binomial. You need to introduce its conjugates. Okay, now how are you going to add or subtract radicals? So it's the same thing with how we add or multiply or subtract polynomials. So to do that, 3a plus 2a, it's 5a. So in radicals, so 3 square root of a plus 2 square root of a, it's basically 5 square root of a. So you need to add or subtract like radicals. So what are examples of like radicals and unlike radicals? So square root of a and square root of a are like radicals. Square root of a and cube root of a, they are unlike radicals. So take note, here the same radicand, the same index. Here the same radicand but different index. Next, these two are like radicals, but these two are unlike radicals. Why? Because they may have the same index, but their radicands are different. Here it's x, the other one is 3x. Next, these two here, they are like radicals, but these two, they are unlike radicals. Okay, why? It's because our radicands here is x squared, but the radicand here is y squared. Next. Okay, these two here, they are like radicals, but these two, they are unlike radicals. Okay, why? It's because this is q plus s squared, and this one is q minus s squared. So again, when you say like radicals, they're radicals with the same index and the same radicand. Otherwise, they are considered as unlike. Okay, now let's have this one. Okay, 4 square root of 3 plus 7 square root of 3. This is basically 11 square root of 3. Next, 9 square root of 5 plus 7 square root of 5 minus square root of 5. So to do this, 9 plus 7, that's 16. Minus 1, so this is 15 square root of 5. Okay, next. Okay, all of this, the same index and the same radicand, so you can simply combine. So 8 minus 9 is negative 1 plus 10, so that would be 9 cube root of 3. Okay, next. Okay, this one, square root of 12 plus 7 square root of 3. The same index but different radicands. But take note, you can rewrite 12 as 2 square root of 3. Then plus 7 square root of 3, so that would be 9 square root of 3. Next. Okay, this one, the same index but different radicals. So take note, you can still rewrite 24 as 4 times 6. You can rewrite 54 as 9 times 6. Square root of 4 is 2 times 8, so that would become 16 square root of 6. Square root of 9 is 3 times 4, so that would become 12 square root of 6. So, adding this, 16 plus 3, that's 19, minus 12, that would be 7 square root of 6. Okay, last. Okay, 4 square root of 7x, it's the same with 16 square root of 7x. So you can combine 4 and 16, so that would be 20 square root of 7x. This one, negative 8 square root of 7y minus 32 square root of 7y. They're also like terms, so combining them, this will be our final answer. So take note, that's how are you going to add or subtract radicals. Now take note, in multiplying radicals, as long as their indexes are the same, you simply multiply the radicals. So for example, square root of 3 by square root of 2, that would be simply square root of 6. Another. Square root of 8 times square root of 3, that's square root of 24. But you can still rewrite 24 to 4 by 6, or that would be 2 square root of 6. Another. Cube root of 6 by cube root of 9. So copy the index and multiply the radicand. So that would be cube root of 54. And take note, you can still rewrite this as 27 by 2. And cube root of 27 is 3 cube root of 2. Next. This one, the same index, so multiply the radicands. So 4 times 5, that would be 20. X by 8, x7, that would be 8. X to the power of 8. Now take note, 8 here, you can still get its cube root. Now cube root of 8 is 2. So times 20, so that would become 40. 8 divided by 3, so that would be 2. And cube root of x squared. Next. Okay, this one. With this, you simply multiply the radical to the terms inside. So this would become square root of 5 by 3 square root of 6, that would be 3 square root of 30, and multiply this, that would be 7 square root of 5. Okay, next. This one, these two here are binomials. So you can use the FOIL method to simplify this. So that would be 5 times 3, that would be 15. 5 by negative square root of 5, you'll get this. Square root of 3 by 3, that's 3 square root of 3, and square root of 3 by negative square root of 5, that would be negative square root of 15. Okay, next. So the same thing, you use the FOIL method. So 5 by 2, that would be 10. 5 by square root of 2, that's 5 square root of 2. This 2 would be negative 2 square root of 2. And negative square root of 2 by square root of 2, that would be negative 2. So at this point, you can still simplify further. 10 minus 2, that would be 8. And 5 minus 2, that would be 3 square root of 2. Okay. Now, what if the given has different indexes? How are you going to multiply them? So, for example, the square root of 2 times the cube root of 2. So, take note, our index here, it's 2, and this one is 3. So, the first thing to do here is to make the index the same. So, since it's 2 here and it's 3, so common to that would be 6. So, we need to rewrite the indexes as equal and adjust the exponents in the radicand accordingly. So, how to do it? So, 6 divided by 2, we will get 3. And 6 divided by 3, we will get 2 here. So, at this point, the indexes are equal. So, copy the index and multiply the radicands. So, at this point, so 6th root of 2 cubed times 2 to the power of 2. So, multiply them, the same base. So, add the exponents. So, this would be 6th root of 2, 3 plus 2. So, that would become 5. Okay, another. Now, this one. This is cube root of 16 times the 4th root of 8. So, different indexes. So, you have 3 and 4. So, common to 3 and 4 would be 12. So, rewrite the index to 12. So adjust the exponent inside the radicand. So to do that, 12 divided by 3, you will get 4. And 12 divided by 4, you will get 3. So take note how it's done. Now at this point, the indexes here are already equal. So with this, it's either you expand 16 to the power 4, or you can rewrite 8 and 16 to the base of 2. So take note, 2 to the power 4, it's 16. And 2 to the power of 3, it's 8. So at this point, you can rewrite this as 2 to the power of 16 and 2 to the power of 9. So at this point, the same base, so add the exponents. So this would become 12 root of 2 to the power of 25. So take note, 25 here, it's still bigger than 12. So 25 divided by 12, so that would become 2 remainder 1. So the simplified form of this would be 2 to the power of 2, or that would simply be 4, 12 root of 2. So take note how it's done. Okay, next. Now, what about division of radicals? Now, to divide radicals, as long as their indexes are equal, so simply divide the radicals. So 8 divided by 2, that would be square root of 4, or simply it's 2. Another. So at this point, so divide this by rationalizing. So to do this, so multiply square root of 3 to the terms here. So that would become 4 square root of 6 minus 5 square root of 15, and square root of 3 by square root of 3, it's simply 3. Okay, next. This one. So 75 divided by 5, that would be 15. 8 divided by 4, that would be 4. And 7 minus 2, so that would be 5. So get the square root of this. So x4, that would be x squared, and y5 would be y squared, remainder 1. So take note how it is done. Now, what about this one? Solve for x. So square root of x plus 3 equals 6. So the first thing to do here is square both sides. So that would be come like this. So you cancel the square root and the power. So this would become x plus 3 equals 36. Transfer 3 to the other side. So that would become x equals 33. And you can always counter check this one. So 33 plus 3, that would be 36. Get the square root to that, that would be 6. Okay, next. Okay, so the same thing here. Square both sides. So you can cancel the power and the radical sign. So 5x equals 3x plus 10. Combine like terms and divide both sides by 2. So therefore, our answer here is 5. Okay, next. Okay, this one. This is cube root of 2x minus 1 is equal to negative 3. So to do this, we need to raise both sides to 3. So with this one, you can cancel this and 3. So this would become 2x minus 1. Negative 3 to the power of 3, that's negative 27. Transfer negative 1 to the other side, so that would become negative 26. Divide both sides by 2, so we will end up with negative 13. Okay, next. Okay, 2 plus square root of x is equal to x plus 12. So to do this, we need to square both sides. So at this point, we need to square this binomial. So square the first, so that would be 4. Multiply first, second, and 2. So 4 square root of x, square root of x squared. So that would be x. So at this point, you cancel the power and the radical sign. So at this point, you combine like terms. So with this, you can cancel x and x. So transfer 4 to the other side. So that would become 8. Divide both sides by 4. So square root of x by 2. So squaring both sides. So therefore, our x here is 4. So again, you can always counter check. So for example, square root of x, 4, this would be 2. So 2 plus 2, this is 4. So substitute here. 4 plus 12 is 16. Get the square root. Still, it is 4. Okay, next. Okay, let's have the sample word problem. A rectangular doormat measures 9 square root by 11 inches wide and 16 square root of 11 inches long. So just like this one. First, what is the perimeter of the doormat? So take note, perimeter is twice of the length and twice of the width. So substituting here, this would become 18 square root of 11 and 32 square root of 11. So therefore, the perimeter of this doormat would be 50 square root of 11 inches. Another. What about the area of the doormat? So take note, area is length times width. So that would be 9 square root of 11 times 16 square root of 11, or that would be 9 by 16, that's 144. Square root of 11 by square root of 11, it's simply 11. So therefore, the area here would be 1,584 inches squared. So take note, when involving radicals can only be used in terms of measurements, no? Because radicals are sometimes, or most of the time, are irrational numbers. So take note of that. Okay, so that would be all about radicals.